In continuation to the PLC automation series, with this video, we will learn about analog input model. In my previous video, I have explained about digital output model, link given in the description box. We will begin this video by understanding the main function of analog input model. This analog model receives continuous real-world analog signals from transmitters and convert them into digital data that the PLC processors can understand and utilize. Digital signals operate only on digital logic like on and off by interacting with the digital devices, while analog signals interact with the real-world parameters like temperature, pressure, flow rate, level, weight, and many. Let's understand working principle of this analog input model along with the wiring diagram. On screen, I have displayed 8-channel 16-bit resolution analog input model. I will explain what is the 16-bit resolution at the end of this video. This analog input model receives variable signal, that is current or voltage from field devices. This model consists of 36 numbers of terminal blocks arranged in this way. We will take field device as a 2-wire level transmitter. First, we will apply 24 volt DC to the model's designated terminals A17 and A18 like this. Now, we will connect 24 volt DC positive from SMPS to level transmitters, and output from the transmitter will be connected to SMPS negative through A4 and A3 terminals like this. Now, the tank level is 0, so transmitter is sending 4 mA signal to analog input model. Now, we will fill 25% water in the tank. In this point, transmitter will send 8 mA signal to SMPS. For 50% water level, 12 mA current will flow. For 75% water level, 16 mA current will flow. Similarly, when tank level is 100%, then transmitter will send 20 mA to the model. This is the wiring diagram between 2-wire level transmitter and analog input model of PLC. Now, let's learn wiring diagram of 4-wire level transmitter. Here, we'll use voltage as an analog output instead of current. The range of the current in the instrumentation system is 4 to 20 mA and voltage is 0 to 10 volt DC. Here, we will take field device as a 4-wire level transmitter. First, we will apply 24 volt DC to the model designated terminals A17 and A18 like this. Next, we will connect 230 volt AC to the level transmitter's power terminals. Analog voltage output of the transmitter will flow from A4 to A2 terminals and return to the transmitter back. Now, the level in the tank is 0. So, the transmitter is sending 0 volt DC to the analog input model. When level in the tank is 25%, transmitter output will be 2.5 volt DC. When level in the tank is 50%, then transmitter output will be 5 volt DC. When level in the tank is 75%, then transmitter output will be 7.5 volt DC. Similarly, when level in the tank is 100%, transmitter output will be 10 volt DC. This is the wiring diagram between 4-wire level transmitter and analog input model of the PLC. Here, it is very important to understand that what is 16-bit resolution in the analog input model specification. 16-bit refers to the analog to digital converter resolution inside the model. Digital electronics having only 2 states, that is 0 or 1. So, if model is having a 1 bit, then 2 to the power of 1 is 2. So, if model is having a 2 bit, then 2 to the power of 2 is 4. Likewise, if the model is having a 16 bits, then 2 to the power of 16 is 65,536 values. For example, 0 to 10 volt range, resolution per step is 10 volt divided by 65,536, which resulting 0.153 millivolt per count. This means for change in every 0.153 millivolt, counts will change accordingly. In the example of 4 to 20 mA range, resolution per step is 16 mA divided by 65,536 is 0.000244 mA per count. This means for change in every 0.000244 mA, counts will change accordingly. Hope this video will be helpful for your understanding about analog input model. If you have any queries, drop your comments. Thank you.